Hi class. In this video, I will give you a tutorial on how to build the Bouncing Ball app, which is the in-class app that goes along with our lecture about return functions and about some of the more unique Sprite properties. You can find all of the information about the Bouncing Ball app, including its functionality and how to set up the app here on Canvas. And you can also view an example of what the app should look like down here with the link of a link to the example of the completed app. So let's take a look at what this app looks like. Here is an example of what the Bouncing Ball app looks like. It's less of a game and more of a sort of animation that will help you in building the homework app, which is the Pong game. So in this app, I have two labels at the top. The first one up here is a timer label that you could have seen started counting from 0, 0, and now is counting up by 1 every single second. Over here on the right hand side, I have a score label that also began at 0 and is increased by 1 every single time the little ball here hits one of the edges of the screen. Speaking of the ball, down here in this big black section on the screen, the black section is the stage. And on this stage, I have a single sprite, which is this little round white ball. This ball, as soon as the app opens up, starts moving and bouncing up and down vertically along the screen, hitting the top and bottom edge of the stage. Every time, again, it collides with one of the edges of the stage, either the top or the bottom, my score up at the top increases by 1. And that is the entire app. We in this app are going to use some of the new properties that we talked about sprites, as well as mix in some functions, both void functions and return functions, to get some practice of building functions from the beginning. Another thing I want to point out about this app is that you might notice the timer is kind of set up a little bit weirdly. It has the 0, 0 colon, but then even though it gets past 60 seconds, it keeps counting up past 60. That's completely fine. That's kind of from an older version of this app where I wanted to have minutes and seconds showed, but I decided it was a little bit unnecessary for this app, so we're just kind of going for a little aesthetics here. So let's go ahead and start building this app together. I'm going to hop over to Thunkable and I'm going to create a new project and I'm going to call it the Bouncing Ball app. I'm going to select the category and click Create. So in this app, I have a couple different visible components. The first are here at the top, which is these two labels for the timer and for the score, and they're situated next to each other, which means they must be inside of a row. So let's go ahead, I'm going to zoom in a little bit here. Let's go ahead and grab a row component. And then inside of that row, I'm going to put two labels. And then below that row, I want to have a canvas. So I'm going to go grab a canvas and place that in here. Okay. So I'm going to go ahead and start renaming and designing some of these elements. So this label on the left, I'm going to call my time label. And I'm going to initialize its text to say 00 colon 00. Then the other label to the right, that's going to be our score label. So I'm going to call it score label. And initialize its text to say the word score, colon, space, and then a 0. You'll also notice that in my example app, there's a decent amount of space between these two items. We could go and just add margin between the two, but if you'll remember from a few weeks back, we talked about some advanced positioning properties. If we go to the row and go to advanced and then positioning, we can select a position, or we can select a position that is relative, and then choose a align items that allows these the children of the row to be spread out a bit more. So I could do, justify content. So I could do something like space between to shove them both to the very edges of the row, or maybe even space around so that there's a little bit edge on space on both sides. That's what I'm going to go with. So I did advanced positioning, my position is relative, and then I chose justify content space around. And then finally, I'm going to go ahead and resize the row to make it a little shorter. So I'm going to choose the height and make it a relative size of, let's say, like 10%. Let me do a quick preview, and that looks pretty good to me. The next thing I want to do is go ahead and style the stage so that its background color is black. So I'm just going to go over to the stage, choose its background color property, and set it to black. And then you could choose whatever color you like. And I'm going to do another quick preview, and that looks pretty good to me. The next thing that I need on this app is a sprite, a single sprite and a single sprite type. By default, Thunkable already gives us a sprite and a sprite of that type to work with. And that sprite should be this, the white ball. If you want to use that image, there is an image here on the assignment. It's kind of hard to see because it's white on a white background, but the image is here. So I could right click and hit save image. Put that in my downloads. And then I'm going to go ahead and upload that image to Thunkable in the file section. And then in order to make my sprite have that image, I'm actually going to go to the sprite type. And then in the picture list property, I'm going to click in this box, select the ball image, hit add, and then I should see that ball image appear. It is also right here. And I can delete the original Thunkable Beaver image by hovering over it and clicking the X. So let's go over to our blocks. And let's talk about the first thing that we want to do, which is to have the ball start moving in a direction, either up or down. This action is going to happen as soon as the canvas loads. So let's go over to the when canvas loads event handler. And in order to make the ball start moving, we can actually do this in two different ways. One of the ways that we've already seen this functionality occur, which was with the Sprite Practice app, was by setting the ball's speed in a certain direction. So that block would be in the motion block, and we can set the sprite speed along the y-axis to whatever value we want for how fast or how slow we want the ball to move. So if I set the ball, which is sprite 1's y speed, to positive 100, that means it'll move downward on the screen in a positive 100 speed. We could also, which is a perfectly fine way to do this app, using some of the new blocks and new properties that we talked about with sprites, we could actually do this in another way, which is by setting the ball's angle. We could do this either in the blocks or in the canvas tab. If we do this in the blocks, we can go to the direction panel and drag out the set sprite's angle to. And in order for the sprite to face downwards, that would mean that its angle is 90 degrees. And now that our ball is facing downwards, it's not going to move. So if I go ahead and preview this, you'll see it's not moving at all anymore. But I could have the sprite move in the direction that it's facing. So I could do that by going again to my motion drawer and setting the ball's speed to whatever value I want in its pointing direction. So I'm just going to choose 100 again. And now the sprite will move in the way that it's pointing, which is downwards. Great. Either way would be fine. If you're going to do when you do the Pong game app, it might be more beneficial to do this movement in this format rather than with the original one that we talked about. But for this app, either way works. The next thing that we want to do is have the ball, once it hits that bottom edge, we want it to bounce back up. We had seen with the Sprite Practice app, a way that we could do that was, again, with setting the sprite's speed, which was this block, and setting its speed to be negative. So every time it collides with one of the edges, we could have its speed either go positive or negative, depending whether it's going up and down, or with the Sprite Practice app, we did left or right. We could actually simplify this a little bit by messing with the sprite's bounce property. So I'm going to go over to my sprite's properties panel, and I'm going to go down to its bounce property. And in my example app, I want the ball to bounce at a continuous constant speed the whole time. And so I'm going to set its bounce to 100, which means that it'll have a continuous speed throughout the entire duration of the app. So just by changing that bounce property, now if I go to the design side, we can see that the ball is now bouncing up and down. Okay. Next, let's go ahead and start talking about the timer. So for the timer, in order to have that this counting up of how many seconds have elapsed, we need to have a timer component because we have some functionality that is based on time. So I'm going to go over to my designer and grab a timer component. And you'll remember some of the properties of the timer component are its interval, which is how often the timer fires. In this instance, we want that label to change every 1 second. And so our interval is going to be 1 second. And you'll also remember that one of the other things we want to talk about is loops, which is if loops were set to false, then the timer would only fire 1 time on its interval, in this case after 1 second, and then it would not continue to fire afterwards. But if we set loops to true, it will actually fire every 1 second, and we'll be able to do some operation every single second, which is what we want to do because we want the timer to loop, to continue to count up every 1 second. So I'm going to go ahead and set the timer's loops property to true. So now let's go back to our blocks. And we want that timer to start ticking as soon as the screen loads. So I'm just going to go ahead and put this in the when canvas loads. And I'm going to go to my timer component. And I'm going to call the timer to start. And you'll remember that call timer to start block triggers the timer's event handler, which is when the timer fires. So what do we want to happen when the timer fires? We want that value to increase by 1. So let's go ahead and create an app variable to keep track of that value. I'm going to call it time. And I'm going to initialize it to 0 because we're going to start with 0 time. And when the timer fires, we want that variable to increase by 1. So I'm going to change app variable time by +1 every second. And then in the label, I want to show that updated time. Because if I go ahead and show you the app right now, you'll see that label isn't changing at all. That label isn't changing at all. The variable's value is changing, but we're not seeing that change reflected in the label. So I'm going to go ahead and change, set that time label's text. And I want it to say 00 colon and then the value of app variable time. Like that. So that I see the 0 minutes and then how many seconds have elapsed. You'll notice one small detail is a little bit off about this, which is that when we have a time that's only a single digit, that it doesn't have the preceding 0 beforehand. And then once we get into the two-digit numbers, it starts to make sense again. But we can actually modify this in the blocks by using a conditional statement, because we only want to show the 00 colon when we have a two-digit number. But if we have a single-digit number for app variable time, we actually want to see 00 colon and then another 0 preceding the single-digit time. So like 00 colon 07 or something like that. So this is going to require a conditional statement where we have some sort of condition that determines what this label is going to say. So let's grab out a conditional statement. And the condition under which we want the label to have this additional 0 is if app variable time is a single digit, which means that it's less than 10. So let's go ahead and say if app variable time is less than 10, then we're going to set the timer labels text to have 00 colon additional 0 and then the single digit app variable time. If at variable time is greater than or equal to 10. So we could do an else statement here. Or if we want to be really explicit, we could do an else if and say else if at variable time is greater than or equal to 10, then in this case, we want to set the time labels text to join together just 0, 0, colon without that additional 0, because then at variable time in this case will be a 2-digit number, 10 or greater. So let's go ahead and test this. Okay, great. So our single-digit numbers have that additional 0, which is great. And then once we get out to our double-digit numbers, we now see that preceding 0 is no longer there. Okay, let's go ahead and work on the score now. So I'm going to create a variable for this score. I'm going to call this at variable score. The score is initialized to 0, and the score increases every time the ball hits one of the edges of the screen, either the top or the bottom edge. So let's go ahead and grab out the event handler for that, which is when a sprite collides with an edge. In the case of our app, the ball will only ever collide with the top or the bottom edge. We could go and specify one event handler for the top edge and one for the bottom edge, but the same thing happens whether it's the top or the bottom edge, and the ball will actually never hit the left or right edge because you've programmed the app so that it only moves up and down within space. So I'm just going to stick with the any edge. And when that edge is collided with, we are going to increase at variable score by 1. Oops, wrong block. We are going to change at variable score by positive 1. And then in order to see that change occur in the label, we are going to set the score labels text to, again, combine the word score so that it always says score colon space, and then the actual numerical value for app variable score. So now if we go ahead and test this, we should see that score increase every single time that ball hits the edge. Okay, great. So now our app is functioning. Let's go ahead and take some of this functionality and transform it into functions. Let's start with the easy one, which would be the WinCanvas loads. So in the WinCanvas loads event handler, we have all this sort of like setup stuff to get the ball pointing in the right direction and to set the timer. So let's just create a function for that, just to give us a little bit of practice with a void function. So I'm going to grab out a function block, and I'm going to call this the setup function. And all this function is going to do is all the things that are in the WinCanvas loads. And then inside the WinCanvas loads, we will call that setup function. And so this kind of gives a name to like what all these blocks do and what their purpose is, which is great. Okay, next, let's go ahead and start working on some of these two blocks down here. I want to make these blocks, I want to turn these blocks into a return function. So my goal is let's start with the when timer fires event handler. I want to recreate a return function that its sole purpose is to update this time label. And in order to update the time label, we have to do this conditional statement to check whether at variable time is less than or greater than or equal to 10, and then return the appropriate string. So either the string that includes the additional 0 or the one that includes no additional 0. So let's go ahead and build this return function. I'm going to call this the update time label function. And in this function, I'm going to do all of this stuff. But what I want to actually happen in this function is instead of just setting the label straight out, I actually want this function to return the string that's supposed to go in this label. And so I'm actually going to take away put this strings off to the side, delete these setters, and inside of here, I'm going to, depending on whether app variable time is less than 10 or greater than 10, I'm going to return a different string. So I'm actually going to take this return block and place it inside of the conditional statement and return the appropriate string. And then I can grab another one of those return blocks from the function drawer here. And in this instance, I'm going to return the singles, without the 0. So altogether, this function will check to see whether app variable time is less than 10 or greater than or equal to 10. And if it's less than 10, it returns this string with the additional 0. And if it's less than 10, it returns a string that doesn't have the additional 0. So when we go and call this block, if we take a look in the functions drawer, here is the function call for that block. You'll see that it has the little notch on the left-hand side, which means that I can't just put it like right inside this event handler. It doesn't clip in because of its shape. So we need to actually attach this block to where we want the return from this function to go. And remember, this function returns the text that's supposed to go into the time label. So I'm actually going to get that setter back out, set the time label's text to the return from that function. So now, altogether, when the timer fires, we're going to increase app variable time by 1, and then set the time label's text to the update time, then call the update time label function. In that function, we're going to check to see if app variable time is less than 10. If it is, we're going to return this string, 00:0 app variable time. Otherwise, if app variable time is greater than or equal to 10, we're going to return the string 00:, and then app variable time. And so then that string will get placed and returned, handed back to where the function was called, and that string will be the value that the time label's text gets set to. Let's go ahead and test that real quick. And we should see that that label is still functioning the way it was a moment ago. Okay, the last thing I want to do is go ahead and take some of the blocks that are inside of this when the sprite 1 collides with any edge and turn this into a return function as well, just to give us a little more practice. So I want to do a similar thing that we did with the update time label function, where we wrote a function that returns the value that's supposed to be set in the score label. So I want this function to be similar to the function that I showed you in the lecture slides, where it increases the value of app variable score and then returns the text that's supposed to go into the score label. So let's go ahead and go to the functions drawer again and grab out this to do something and return block. And the purpose of this function is to update the score and return the text that goes into the label. So I'm going to call this update score and label function. In this function, we're always going to change app variable score by +1. So I'm just going to go ahead and take this block and move it into this function, the change app variable score by +1, because that's the value that the score is going to increment by every single time. And then I also want this function to return the value that's supposed to go into the score label, which is this join of the word score and the value for app variable score. So I'm going to take that block and put that as the return value for this function. And then that's the entire function. So this whole function, the update score and label function, changes app variable score by +1, incrementing it by 1. And then it returns the string score : space and then the value, the new value of app variable score. So now we need to call this function. This function is supposed to occur when the sprite 1 collides with any edge of the screen. And the returned value from this function should be placed into the score label. So let's go ahead and go over to the function drawer. You'll see the new function call block for the update score and label function. And you'll notice again that it has that little notch on the left-hand side, showing that I can't just place it right inside of the event handler because it's not the right shape. It won't click into place. It needs to be attached to some other block. Again, the block that this needs to be attached to is wherever the return from that function should live. In this case, it's returning the string that should go into the score label. And so I'm going to attach this block to the setter for the score label's text property. So altogether, this works like this. So when the sprite type 1, so when the ball collides with any edge of the screen, I'm going to set the score label's text to, then I'm going to call the update score and label function. In that function, I'm then going to change app variable score by +1, and then return the string score : space, and then the new value for app variable score. That string is going to be the value that's returned or handed back to where the function was called. And so that value is going to be the value, that string is going to be the value for the score label's text. So now if we go ahead and test the app again, you should see that everything still functions as it did before. The score is still counting up every single time the ball bounces. And that altogether is the Bouncing Ball app. We went through some of the new properties of sprites with the bounce property, and also took some of our new knowledge about return functions and applied it to some of the functionality in this app with the timer label and the score label. You can go ahead and submit this with the project details page on Canvas as usual, and that is all. Thank you.